Welcome to this video that aims to help you get started with crime analysis in ArcGIS Pro. Over this video, I want to show you how we can load some data, visualize that information, run some basic analysis, automate your workflows, and some more advanced techniques at the end. But to start off, I just want to talk a little bit about the interface for those of you that have never used Pro before. Over on the left hand side here, I've got my table of contents, and as data is added to the map, it will appear here, and we can turn layers on and off as you would expect. Along the top here, we've got access to a variety of different tools, including the crime analysis toolbar that's an optional install. Now, if you don't have that toolbar, don't worry, because the same capability is available in the crime analysis toolbox, which is included by default. And over on the right hand side here, we have my catalog pane, which really differentiates Pro from some of our previous desktop applications in the fact it's very much a project process. We want to bring together a variety of maps, different databases, connect to a variety of different folders so we can bring all of our information together in one place. I'm now going to show you how we can load in a spreadsheet of crime data that has been downloaded from the Police Open Data site. So for that, I go to my map tools, and there's an option here called XY table to point. What this is doing is it's allowing me to point at a table or a spreadsheet and bring that into ArcGIS Pro as a geographic data set. So the first thing I'm going to do is navigate to where that CSV can be found. I'm then going to give my data a name, so we'll just call it crime for now. You'll notice it's automatically picked up that this data includes some coordinates. We've got long and lat in there. And then finally at the bottom here, we need to define the coordinate system. So long and lat means that we're going to be using a global coordinate system, but if you're using British National Grid data, do please make sure you change this coordinate system to the appropriate value. If when you load data in, you're finding it's arriving in the middle of the sea or just is not in the right place, there's a good chance you've chosen the wrong coordinate system. So I'll quickly run that now, and that will add that to my display. And we can now see the crime data has been visualized within the map. And if I click on it, we can access any of that really great underlying data. Or alternatively, I can open up the attribute table to review that in a little bit more detail. Now that we've loaded the data, I'd like to show you a few visualization techniques so we can better understand this data. Now, the first thing I'd like to show you is how we can represent this information as a simple heat map. So to do that, I go to the Symbology tab. And at the moment, we've just got a single symbol displayed. And if I wanted to, I can change that symbol by choosing from a variety of different options from my gallery, or I can configure the look and feel of the existing symbol. So that might be changing the color, changing the size, etc. What I'd like to show you, however, is if I choose single symbol, there's a variety of different visualization techniques available under here. And down at the bottom here, we can choose heat map. Now what heat map will do, it will create a visual representation of the distribution of this crime information. At the moment, I think it's a little bit broad. That radius is slightly too high, so I'm going to reduce that down a little bit, and now we've got a little bit more definition on where the hotspots are. I'd also like to change this from constant to dynamic, and what that means is as I zoom in and out of the map, I'll get more and more detail, so I can start to understand this information in a little bit more detail. So for example, if I zoom down to this particular hotspot here, you'll notice that it's reworking itself out. It's giving me more detail as I zoom in, so that initial one massive hotspot can be broken down into a smaller number of more focused areas. So really nice technique. We're not actually running an analysis here, we're just visualizing the data in a slightly different way. Another nice technique is called clustering. Now for that I'm going to turn my data back to single symbols, but I'd like to visualize based on the different types of crime. So if I do unique values, and under my field drop down I choose crime type, what you'll notice now is it's visualizing each different crime type with a different color. Now I'm not massively keen on the color scheme that's been chosen by default, so I can choose an alternative if I so wish. So this is helping me understand the different types of crime across the different parts of Hertfordshire, but it's really difficult to pick out, well, where is most of the activity taking place. So this is where clustering comes into play. I can go up to the feature layer context menu here, and we can do some dynamic aggregation. Now there's a couple of options, clustering or binning, but the one I want to show for now is clustering. When we turn that on, what we can see is it's aggregating points that share a similar geography into one large cluster. Now at the moment, I think the clustering tolerance might be slightly high, so I'm going to adjust that slightly so it's looking for a smaller area. I also think the symbology perhaps is a little bit large at the moment, so I can go into the cluster options under symbology to reduce that down just a tiny bit. Now we've done that, let me explain what clustering is doing. So you'll notice it's brought those points together into clusters, and we can see a count of the number of crimes that are represented in each. But the color is also showing us the predominant crime type in that area. So it's a really nice way of seeing not only where are most crimes happening, but what's the dominant crime in that particular location. And as with the heat map, it will dynamically change as we zoom in. So as we zoom in on this particular cluster, we're getting more and more detail as we drop down to street level. So those two techniques are really nice ways to start looking at the data, better understanding it, before you start running your first true analytical techniques. Now that we've looked at visualization, let's now look at some of the more analytical approaches. So I'm going to zoom back out, and we're going to turn off clustering. And if I go to the crime analysis toolbar here, what I want to do is I'm going to show you how we can use summarize incident count to better understand the distribution of crime across this area. Now to do that, I need some sort of geography that I can aggregate my data to. Now I happen to have a grid data set here which will be perfect for this analysis. Now I'm using a grid just because I think a uniform size makes the analysis easier to understand, but this could just as easily be districts, postcodes, LSOAs, whatever sort of geography you're most interested in. So if I choose the Summarize Incident Count tool, it's only got a few options for me to configure. Now the first one is what the input features are going to be, so that's my grid. My summary features is going to be the crime data. We'll create a new data set called Incident Count, and I'm going to create a group field of crime type. Now what that's doing is it's going to create a data set that not only tells me the total number of crime in each area, but also is giving me a count of each individual crime type. So if we open this up, we can see that this is giving me the distribution of all crime across Hertfordshire. And if I select one of these particular areas, we can see that down at the bottom here, we've got the total number of crimes in this particular location, but it's also including the count of all those specific crime types. And that's really useful because if I go to the Symbology tab, I can now change the way the data is displayed. So rather than looking at all crimes, I can change that to be violence and sexual offences, or I could look at robbery. So it gives me a lot of flexibility on the way I want to display this particular data. This analysis process might be something you run on a fairly regular basis. What I'd like to do now is show you how we can automate that multi-step process into a single tool. Now if I look at the history, I can see that we've run two tools as part of this analysis so far. XY table to point was used to load the data, and then summarize incident count has created this nice view of the distribution of crime. What I'd like to do is create a model that runs both of those processes as one step. So if I go to my catalog, you can see that we've got a toolbox here which is currently empty. I'm going to right click that and say I want to create a new model, and it's going to open up Model Builder here with a blank slate. If I go to my history, I can drag both those tools in, and it recognizes the fact that they're collected as a workflow. So we've got the CSV that was loaded to create a crime data set. We join that to the grid to create the incident count. So already I've created a simple tool that allows me to replicate that process. But what I'd like to do is enhance this by providing a little bit of user input into my model. So by making some of these elements parameters, that's allowing the user to adjust that at runtime. So for example, it might be I want to run a different CSV. It might be I have a new data set. So I want to allow the user at runtime to select a different CSV. I also want to give them the option of changing the boundary dataset they use, give them the ability to name the crime dataset as an output and the incident count. So if I now save that and go back to my map, what I'm going to do is I'm going to remove the analysis we've done so far and then just run that model. So you can see it's asking us to point at the CSV, the reference geography, the two outputs that we're creating. If I run that, it's going to run all of that as one single process. So this is a really nice way of automating common tasks that you use on a regular basis. So you can see that it's already loaded the crime data and that analysis we ran. Now this is a fairly simple example, it's only a two-step process. But what's worth considering is, are there workflows that you use on a regular basis, daily, weekly, monthly, that could be streamlined by making a model to do that work for you? It's also a really good way of sharing your analytical approach with colleagues who might be trying to achieve the same thing. You can share the model, then they can run it against their own data. So creating models are a really great way of optimizing and automating your workflows. One thing I forgot to show in that last analytical section was how we can filter this data down to just see the top 10 locations. So to do that, it's very easy. If I open up the attribute table for the data we've just created, we can see, as I've highlighted before, all the different crime counts. Now, if I was to order the total count descending, we can see that the worst areas got 128 all the way down to some areas which don't have any. Now, if I wanted to choose the top 10, I can see that anything of 68 and above are going to be the ones which I'm most interested in. So to filter this data down, I double click, open up my properties pane, and then create a definition query where we say total count is greater than or equal to 68. And when I apply that, it's now just showing me the top locations which are perhaps most applicable for patrol plans as part of the Home Office funding. For the final part of this video, I'd like to show you some slightly more advanced capabilities for crime analysis. So the first one I'm going to show you is how to run the kernel density tool. And for this, we're going to just look at antisocial behavior. Now at the moment, I've got all data on display. And if I want to change that, I can double click my data layer and run a short definition query, which allows me to filter down the information I'm interested in working with. So by choosing crime type is equal to antisocial behaviour and applying that, we're now just looking at the antisocial behaviour crimes. Now when we're looking for tools such as the kernel density, the best way to find them is to go to the geoprocessing tab and simply look for the keywords. So kernel densities come up at the top here, and there's a small number of parameters that we need to define. So the number one is which data set are we running this against, and I can choose whether I want a population field, but we don't have one. I'm going to create a new output called kernel density. I'm not going to change the cell size. It's generally pretty good at choosing an appropriate cell size for you, but you can adjust it. And I'm going to leave the other elements as is. When I run that, it will very quickly produce me the new output where I can see the results of my analysis. The next tool I'd like to show you is the 80-20 tool. Now what the 80-20 tool is aspiring to do is find where a large number of crimes are happening in a very small area. So I'm going to run the 80-20 tool. I'm going to point at my antisocial behaviour. We're going to produce a new output called crime 80-20. I'm going to choose the cluster aggregation method, and then I want to define a tolerance that is the area we want to look across when we're trying to find related crimes. So if I say 200 meters, that's going to look for clusters of crime that are happening within 200 meters of each other. I'll set that running. And when this adds to the display, it will have all those clusters visualized for us. Now when it first gets added, you can see it has picked out a couple of strong clusters, but it is also including all the other much less important clusters as part of this analysis as well. So what I would typically do at this point, if I open up the attribute table, I can see a count of the number of incidents that are associated with each particular cluster. Now if I wanted just the top 10, we can see that anything 12 and above is going to be those key areas. So I can create a short definition query where I'm saying I'm interested in where incident count is greater than or equal to 12, and that's now going to filter down the display to just show those most important incident locations. So a really nice tool for picking out those key locations where perhaps a patrol would be a really good idea. The next technique I want to show you is called space-time analysis. So this is a temporal technique where we can use time to understand, well, how has crime patterns changed over time. Now this is a two-step process. So the first thing we need to do is create a space-time cube that then feeds into our emerging hotspot analysis. So if we do the space-time cube first, we're going to choose the antisocial behavior again. We're going to create a new output. We'll call it demo. I choose the time field, which is my date. My time set interval, so this data is 4 months worth, so I'm going to look at a 1 week increment. I'm going to align that with the start. And I'm going to use my existing grid data. So you could ask it to generate a grid for you, but I'm just going to use the existing locations I've already been using in the rest of this analysis. And we need to define an ID for each of those grid squares. When I run that, you won't see anything specific change in the map interface, because all that's done is that's created the background data set which we need to feed into the next step, which is emerging hotspot analysis. So I'll run that, and this is where we point at that file that we've just created, which is the demo here. The analysis variable is going to be count. We're going to create a data set called emerging hotspot analysis. Now we could choose neighbors based on a fixed distance or the number of nearest neighbors. Now because I'm using a hexagon, it makes sense to me to have 6 nearest neighbors, but you can adjust this as you so wish. I'm going to run that against the entire cube. What this has done now is it's created a really nice visualization that helps me understand how things have changed over time across Hertfordshire. So if we zoom down here a little bit, we can see that this dark red is representing areas where we've got a persistent hotspot. So these have had high amounts of crime across that complete 4-month time period. Where we're seeing the slightly lighter red, that is a intensifying hotspot, so that suggests that things are changing over time with an upwards trend. These lighter pink areas are good news. They're diminishing hotspots, so they were a hotspot, but they seem to be dropping off now. And finally, this spotty pink area is showing where it's been a hotspot, but it's been oscillating up and down over time. Now, if you want to understand the science behind this tool, then I do recommend then just click the question mark here, because that will give you a lot more detail in our online help. So emerging hotspot analysis is a really good way of understanding, well, how have things changed over time, particularly if you've been taking action in a particular location, because ideally you want to see crimes on the fall. So the final technique I want to show you is how we can compare 2 different time periods against each other. So for this, I've got antisocial behavior again, but I've got 2 slightly different time periods. So I've got a definition query saying I'm only interested in June and July in this particular data set, and then the latest data I've got August and September. And I want to compare these 2 against each other. So I go to my crime analysis tab, I run the summarized percentage change. I need to choose a grid data set, which we're going to be using as the reference background data. The current period is my after, my previous period is before, and it looks like I haven't saved. Oh, I have. You'll notice here that it's saying it's going to be using the filtered records. So it's important that I do have those filtered records because they're filtering not only by ASB but by the date range I'm interested in. And I'm going to create a data set called percentage change. We'll run that and the results will quickly appear on screen. Now when this first loads in, the outlines of these grid squares are a little bit heavy for my liking. It makes it very difficult to understand. So I'm just going to subtly adjust my symbology. So if I go to the More option here, I can format all my symbols because I want to reduce the size of that outline so that it doesn't take up so much of the map space. So that's now a little bit easier to read. And what we can see here is the areas in red show percentage change that is, fairly high, and the blue are showing areas where the percentage change has dropped down. So really nice way of comparing 2 different time periods to see how things have changed over that particular period. So hopefully you found this video of interest. Hopefully it's given you a good starting point for getting up and running with crime analysis in Pro. I will be doing other videos over time, so I think next up we'll be looking at creating web applications in either our online or enterprise environment. So hopefully I'll see you there. Thanks very much.